Welcome. This video on L'Hopital's rule is brought to you by the Learning Center at Vancouver Community College. Visit our website at www.vcc.ca/tlc for more information. We're looking for requests, so please submit your suggestions to mathsciencetutor@vcc.ca. The question asks us to evaluate a series of limits. If we try the obvious strategy of plugging 1 into the problem, we get a division by 0. However, it's not as bad as it could be. 0 over 0 is an indeterminate form, which means it could resolve to a finite answer. We can use L'Hopital's rule to evaluate the limit. The rule says essentially that we can differentiate the parts of a fraction and try evaluating the limit again. We differentiate the numerator and denominator, and we find that the limit of the resulting fraction is pi. So L'Hopital's rule tells us that the answer to the original problem is pi as well. It's important to distinguish this from the quotient rule of differentiation. The derivative of this limit would be very different. L'Hopital's rule is very specific. The limit must be 0 over 0 or infinity over infinity. There are other indeterminate forms, however, that L'Hopital's rule doesn't directly address. This limit results in an indeterminate product, 0 times infinity. But L'Hopital's rule can't be used on it in this form. It's easy enough, however, to simply rewrite one factor as its reciprocal and divide. Then we can apply L'Hopital's rule. It's possible that the resulting limit is also indeterminate. That's fine. We just apply L'Hopital's rule as many times as necessary, until we get something that is not an indeterminate form. We can also have differences as indeterminate forms. In these cases, we either find a common denominator or find a common factor. We can rewrite the non-leading term in the radicand, the x, as a fraction with x squared as a numerator. Then factor the x squared out of the radicand as a common factor, and do the same thing for x in the overall expression. Now it's an indeterminate product. Write one factor as its reciprocal and divide. L'Hopital's rule should straighten everything out. The last kind of indeterminate form is an exponential expression. 0 to the 0, infinity to the 0, and 1 to infinity are all indeterminate. We can introduce a logarithm into the limit, much like we do for logarithmic differentiation. This lets us break down the exponent and make it a coefficient. One of the limit laws allows us to move the e to the x part of the expression outside the limit. We can now work on our new exponent. It's a quotient now, so L'Hopital's rule will work on it. That's L'Hopital's rule. If you'd like more detailed information and some practice problems, look for the L'Hopital's rule worksheet for Math 1100 on our website, vcc.ca/tlc.